Right, here we go. Here's the answers for section 2, long answer questions. Number 1. So you've been given a charge and you've also been given a time, and you have to calculate the current. Knowing those three things, you should have got this. Q equals IT, which you get 1 mark for, and then rearranging it, I equals Q divided by T, which is 24 divided by 0.0012. You should have got 20,000 amps or 20 kilo amps if you put that. You get 1 mark for plugging in the numbers, and then you get 1 mark for your answer and the correct unit, and it's 3 marks in total. Mark yourself out 3. Right, this is a bit of a problem solving question. They've told you that the charge on an electron is minus 1.6 times 10 to the minus 19. So you to determine how many electrons were transferred during that lightning strike. You know there was 24 coulombs, and the charge on each one is 1.6 times 10 to the minus 19. That should give you 1.5 times 10 to the 20 electrons. That's how many there were. Quite a lot. That was 1 mark for that, if you got it. Right, many buildings contain a thick strip of metal. What is the purpose of this metal? It's 2 marks, so you need to explain what the metal is and what it does to help. So you get 1 mark for saying metals are conductors. So it's going to take the electricity instead of the building, and more current will pass through the metal than the building. Something along those lines will get you the 2nd mark. Right, a little bit of electricity. Complete the diagram to show where a voltmeter would be on a resistor. Resistors is this thing down the bottom. Variable resistor, you've got an ammeter. Ammeters are in series. Voltmeters need to go in parallel. So either side, because it's measuring the potential difference, either side of the resistor, so you get 1 mark for that. Describe how the student obtains a range values of voltage and current. Well, you've got a variable resistor here. A variable resistor's got either a button or a knob on the front that you can turn, and then that will change. You can increase or decrease, vary, change the resistance. And as you change the resistance, the voltage and current can change in a circuit. So you would need to write something along the lines of the variable resistor can change, it can increase or it can decrease its resistance, therefore voltage and current can therefore change. Something along those lines. It's 1 mark. Right, this one's 4 marks, and you have to use all, it says use all these results to determine the resistance of the resistor. So this is going to be using Ohm's law, because you've got the voltage and you've got the current. R equals V over I. So for the top one, you've got 1 over 0.2. For the second one, you've got 2.5 over 0.5. For the third one, you've got 3.2 divided by 0.64, and for the last one, you've got 6.2 divided by 1.24. And if you calculated all those, every single one of them gives you 5 ohms. So that is the resistance. You get 1 mark for quoting Ohm's law. You get 2 marks for putting in all the results because that's what it asks for, and then your final mark is for stating it's 5 ohms. Right, part D. State a conclusion that can be made about the resistance. So you've got the voltage and you've got the current, so you know if the resistance was constant, then the graph would go directly up like that, but the graph doesn't go like that. So the resistance is changing or not constant, you could have wrote, or increasing, not decreasing, increasing. 1 mark for that. Right, number 3, this is a show that question. Show that the minimum energy required to increase a temperature. So as soon as you see a question that's increasing temperature, that should be triggering EH equals Cm delta T. From your data sheet at the start, it's water that's in the machine. So the specific heat capacity of water is 4,180 times the mass, which is 6 kilograms, times 15 up to 40, which is an increase of 25 degrees. 627 kilojoules, or 627,000 joules. 1 mark for the equation, 1 mark for plugging in your numbers, and because it's a show me question, it's only worth 2 because you've shown 627,000. Right, next one. So the power it's telling you is 1800. You've already calculated the energy and it's asking for the time. You should all know that equation. T equals E over P. 627,000 divided by 1800, which gives us 350 seconds. 3 marks, 1 mark for the equation, 1 mark for plugging in, 1 mark for your answer plus units. Explain why it takes longer in practice. It'll take longer because heat is lost to the environment, or just lost to the washing machine drum, anything along those lines, but it's heat lost is essentially what's happening, so it will take longer than the 350 seconds quoted. Right, good old transistor question. Explain how the circuit operates to switch off. So it's 3 marks, so you need to be quoting 3 things. So it's telling you, the thermistor, as the temperature goes up, the resistance goes down. We've done this third. So if the temperature increases, the resistance decreases. If the resistance decreases, then the voltage also decreases. And remember, when the voltage drops below a certain level, the transistor switches off. So you get 1 mark for saying the voltage goes down, you get 1 mark for saying the transistor then switches off, and then the last mark is for saying the relay or the switch then which is off. Final mark. 3 marks in total. Right, number 4. Waves. A detector of infrared radiation. You could add a few things here. So a black bulb, thermometer, photodiode, thermocouple, those were the main ones. Right, part B. State which radiation in the spectrum has a wavelength shorter than X-rays. So in here is gamma rays. Radio is up here. Roman men invented very well for X-ray guns. So gamma is your answer for there. Another show me question. So you've got the frequency, 1.2 gigahertz. 1.2 giga means times 10 to the 9. You know the speed, everything in the electromagnetic spectrum travels at 3 times 10 to the 8, and you want to show that the wavelength is 0.25. So wavelength equals speed divided by frequency. That's your first mark. Second mark is putting in the right numbers. 3 times 10 to the 8 divided by 1.2 times 10 to the 9 equals 0.25 meters. 1 mark for the equation, 1 mark for putting in the right numbers. Identify the part of the spectrum that this wave belongs to. So where is 0.25? Here's 1 meter, and then 10 times 10 to the minus 2 is 1 times 10 to the minus 2, which is 0.001. No, it's not. It's 0.01. So anything in that range there is microwaves, and 0.25 is between 0.01 and 1. Therefore, it's microwaves. You should add in there 1 mark. Number 5 you couldn't do. Number 6, you had to draw on the normal. Remember, the normal is at right angles. So that's your normal there. Make sure you did the dashed line and you labelled it to get the 1 mark. Angle of incidence always goes from the normal to the line. Angle of refraction is inside the new, inside the block. Refraction from the normal up to the line. Not in here, not in here, not in here, not in here. So you had to get both of those to get the 1 mark. Part B is involving this graph. And it says determine the angle of refraction, which is this side, when the angle of incidence is 12 degrees. So we've got 10 here. Each of those blocks is worth 2, so this is 12 here. And if we go all the way up and then all the way down, that's 2 blocks below 10. So the answer is 8 for that one. Use the graph to predict the angle of refraction when the angle of incidence is 80. So when the angle of incidence is 80, which is here, all the way up, you want to try and continue that graph on, and I got it to be about there, which is 1 peak above 40, so around 41. But the marking scheme was allowing any answer between 40 and 42. And why do we repeat experiments? You should have been writing something along the lines of obtain more reliable results, or take an average. Could have wrote that. It's more accurate to do it that way and take an average. Something along those lines there to get your 1 mark. Number 7 you couldn't do. 8 you couldn't do. 9 you couldn't do. And 10. Or 11. 8, 12. Calculate the total weight on Earth. There's your clue. Weight equals mass times gravity of the it's the total weight of the spacecraft, which is this number here, not any of the individual ones. So W equals mg, 1 mark. 3 times 10 to the 3 times gravity, which you get from your table at the start. 1 mark for putting those numbers in, and then get 1 mark for the answer, which is 2.9 times 10 to the 4 newtons. The energy change in a photovoltaic cell is it takes light in, so it converts light energy into electrical energy. Right, part C, suggests why these rotate. These need to take in light energy, and sometimes the sun might be behind the structure, it may be in front, it may be at the side. So a good idea is to have these rotating so it can maximize the amount of light received. 1 mark. Calculate the total energy. So you want to work out energy during 2 hours. So 2 hours times 60 times 60 gets it into seconds for you. Sixty times 60 says that's 7,200. And it's 5.25 AU. So if you go back up to your table, 5.25 AU is equivalent to 395 watts. So now you've got your power, 395 watts. E equals P times T, 7,200 times 395, which should have gave you 2.8 times 10 to the 6 joules. 3 marks. 1 mark for the equation, 1 mark for plugging in the right numbers. If you didn't convert the seconds correctly, you would only lose 1 mark because it's a mistake carried through. 12C and D we couldn't do. 13 was just about reading the passage. State what is meant by the term nuclear fusion. You just have to pick it from the text. That's 2 nuclei combine to form larger nucleus, 1 mark. Determine the average temperature of the sun in degrees C. It gives you it in 5778 Kelvin. So you need to take away 273,5505 degrees C, 1 mark. And that is the end of the question paper. So lastly, if you go to your OneNote, and go to your Christmas homework page, this one here. This full paper was out of 57. So what I'd like you to do is put your mark in there in your OneNote page and then fill out your strengths and your next steps depending on what ones you got right and which ones you got wrong. That's your task for this lesson. So on you go. Good luck.